What's going on, guys? Let's do this problem right here. So here we have this much water in the cone shape, and we have to pump this out of this cone. And the question is how much work required to pump this out. So let's see how we can find this one out. So to find this one out, what we do, we cut a small part of this water. So if you cut this part like this is a like cylinder shape, right? So cylinder shape, what we do, so first we find out the volume. So volume of cylinder, we know that pi r square h, pi r square h. So if I cut this distance, let's say this distance is y distance from here to here, y. If it's y, and if this small height is dy, and we are trying to find the dv, the small volume right here. To find the small volume, we can use pi r square dy, right? This is going to be the volume equation. Then what we do, like our purpose is to find the mass, because we are talking about the work, right? Work is equal to force times distance, and force is equal to mg. Force is equal to mg. So we are trying to find the mass right here. If we find the mass, we can calculate the force. Then by using the distance, we can find the work. So let's find the mass. Mass is going to be basically, if you notice that density is kilogram per meter cube, and volume is meter cube. And if you multiply density times volume, that's going to give you the mass. So here, if we say dm as the mass of this small part, so that's going to be equal to rho times dv. dv is the volume, and that's going to be equal to rho times pi r square dy, right? So this is the relationship we formed right here. So let's see how we can calculate the work using this information. So dw is going to be force times distance. So force times the height. So we are talking about the height to pump this one. So the distance here considered as the height. So force times height. To find the height, we have to find the distance from here to here. That is going to be what? Here the total distance we know 8, and this distance is y. So to pump this part from here to here, we have to bring this one this much height. So that's going to be basically 8 minus y. So here the height is going to be 8 minus y. Now we can substitute everything and find the work, right? So let's rewrite this dw in terms of this height. So dw is going to be equal to force times height. Force is dm times g. So dm is mass times distance. Force is dm g. We are talking about the small part right here. So that's going to be dm g times the height, that is 8 minus y. So now we have formed an equation. Let's find the work, right? So here what we are going to do, so we are going to cut each part of this water into small pieces and calculate how much work required to bring the whole water out of the system. So to do that, we have to integrate from 0 to 6, because if you see the height of this water, it's going from 6, the height is 6 meter. So the limits of integration is going to be 0 to 6 meter. So 0 to 6 dw. Now we can replace the dw with this equation. That's going to be 0 to 6, and instead of dmg, we already calculated dm, rho pi r square dy. So we can replace this one with this one. So this is going to be rho pi r square dy times g times 8 minus y, right? Now everything except y is going to be a constant, because we are integrating in terms of dy. But also this radius, we can convert this one in terms of y. If you notice the relationship, r is equal to half y, therefore r square is going to be equal to 1 over 4 y square. So we can replace this one with that one. So let's bring all the constant to the front. So we are going to have 1 over 4 rho phi g outside, and inside the integral we are going to have y square 8 minus y dy. right? So let's do the multiplication. So if we multiply this one, this is going to give us 1 over 4 rho phi g integral 0 to 6 8y square minus y cube dy. Now this one is easy to integrate, so let's do the integration. So this is going to be 1 over 4 rho phi g. If we integrate this one, this is going to be 8y cube divided by 3, and the other one is going to be y power 4 divided by 4, and that's going from 0 to 6. So let's plug the values and see what we get. Right, so let's do the substitution. Let's continue this one right here. So we have 1 over 4 rho phi g. So inside derivative, first we are going to substitute the 6, and if you substitute and calculate this value, you will get 576 minus, if you substitute 576 for this one, minus here if you substitute 6 power 4 divided by 4, that's going to give you 324, and if you substitute 0 for this one, that's going to be 0. So subtracting 0, that doesn't make any difference, so I just omit that part. So we are only going to have this part, and if you calculate this one, this is going to be 252 divided by 4 rho phi g, and rho is density of water. That's going to be 252 divided by 4 times 1000 kilogram per meter cube times 5 times 9.81 meter per second square. And if you calculate this one, that's going to give you 1.94 times 10 to the power of 6 joule. So this is the amount of work that is required to pump all the water out of this system. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.